All right, friends, in this little video lesson, what we're going to do is do an introduction to our next unit. So as you're watching this, you should also have the notes open and should be filling those in. Remember, you can find the notes in your student files in the new folder on atomic theory, or atoms, elements, and ions is our new folder. So I would go get those notes first, pause this probably, and they should say student notes for you to look at, and then we will go from there. Okay, so the goal of this video is to talk about what do we know about the whole atom, what are the elements, and how do we form ions. So here we go. So first of all, we're going to talk about a little bit of the sequence in which we discovered different things and kind of what they are inside the atom. So hopefully some of this is review for you. First of all, where does this idea of atoms come from? Well, atoms come from the Greek word atomos, which means uncuttable. So early Greeks believed that there must be some particle, something that is very, very, very tiny, that is the smallest, undivisible or unbreakable or uncuttable particle out there. So they started calling that the atom, basically. Okay, scientists began to study this in the early 1800s to see if they could find this particle that the Greeks had philosophized about. Okay, and we did believe that they could not be broken into smaller parts, even though now we know they can. At the point, they kind of thought that there would be some sort of spherical shaped object that was the very smallest piece of anything that we had that existed, and they called that the atom. Okay. Now, as research continued and we learned more, we've discovered something called the electrons. Okay, they are the first ones to discover because they had these negative charges that we could manipulate through magnetic fields and electricity. So then we said, hey, there's these little particles that are being controlled by putting charge or electricity through it, and then they discovered that they were electrons. Okay. Or we named them electrons over the idea of electricity. Okay, this did change the view of our atom. So now that we had this idea of electrons, we knew that there was things inside of the atom. So we knew there was particles inside there that we called electrons, and we knew that the whole atom was neutral. So being that the whole atom was neutral, they knew there had to be something positive in there, but we had yet to figure out what that was. Okay. These are definitely smaller than the atom itself. They definitely have a negative charge. And we do know the atom is neutral because they could tell that again through using electricity. And so we're trying to find that positive thing. Now, interesting thing, when discovering the electron, the scientist, his name was J.J. Thomson, he used a device called a cathode ray tube, okay? And that was a way he said could send electricity in and bend basically electrons. That cathode ray tube later became our first TVs. Okay, so this little scientific tube that he had used, that was built by a guy named Crook, that tube then became the device that turned into a TV later in life, because bending and beaming electrons onto a screen is essentially how our first TVs were created. So yeah, so it's kind of interesting how a scientific thing that's really about all sciencey stuff turns into something that we use a lot in our daily lives. We kept on learning more. All right. So now we're in the 1900s, early 1900s, and we found the nucleus of the atom. Okay. So the nucleus of the atom is a tiny core in the middle of the atom. Okay. So it's a tiny little spot in the middle of the atom. We called that core the nucleus. Okay. It does have a positive charge to it. So we knew that that core had a positive charge to it. As it had. It takes up very little space, so its volume is very small, but has almost all the mass. Okay. Now, what about those electrons? Well, those electrons that we had found earlier, they know that they are outside the nucleus someplace. So we go from thinking that the mass and the atom is kind of all one ball of stuff to realizing that there's a core to it that has all the mass, has a lot of empty space out here, but those little electrons are in that empty space. Okay, so here's a little simulation of kind of how they figured that out. So this is called Rutherford's gold foil experiment. Okay, and if I turn on some alpha particles and I beam alpha particles, and that's what they did, they beamed these alpha particles at a really thin piece of gold foil. And what they expected to happen is either have all the particles go through because the gold was thin enough that the alpha particles would just fly through it, or have them all bounce back. That was the expectation. What they found is that some of the particles went straight through. Like this one here is going to go straight through, left alone, and some of them got deflected off at some sort of weird angles. Okay, so what they found is because there's these deflections inside of the gold foil. So this is the foil here. This is kind of showing a top view of the foil. These are little gold atoms here. Because of all these deflections, they were able to measure these deflections on a screen. And as a result, they said, well, wait a minute. Most of the time it goes straight through, but every once in a while we get these weird deflections. There must be something really big and massive in a core. Not big, sorry, very massive, lots of mass, but tiny inside that atom where all that mass is at. So that's how they were able to find the nucleus, but basically by beaming some things called alpha particles at really, really, really thin gold foil. Kind of cool. Now, after we learn about the nucleus, then we start to focus on that nucleus. So it's like, okay, we have this tiny core. What's inside of there? So that's where we found the proton. Okay, so the proton is this positively charged particle. We did find it inside the nucleus. We found out it was 2,000 times heavier than the electron. Okay, so the electron was tiny, tiny, tiny. And we know that the proton is 2,000 times more mass than the electron was. So it's a gigantic particle in comparative to the electron. Okay. Now, these atoms are neutral because we realized that the protons needed to be the same as the electrons. So if there was 1, 2, 3, 4, 5, 6, 7 electrons, there had to be 1, 2, 3, 4, 5, 6, 7 protons in there. So they had to have the equal number of protons and electrons to keep the atom neutral. Okay, this was all kind of being learned about the 1920s now. So you kind of see the progression is like the early 1900s, late 1800s, where all this research was being done. Okay, but they knew that there was more mass to find because they knew the mass of the atom and the protons wasn't all of it. So they kept looking for what is the other thing there that has the rest of the mass. And they didn't find that until the 1930s, and that's when the last particle was discovered, which was our neutron. Okay, so the neutron was discovered last. Okay, it has no electronic charge. It is in the nucleus. And its kind of job, because it doesn't have a positive charge or negative charge like the other two, it has kind of an interesting job. Its job is to just kind of help keep everything stable inside this nucleus, okay? So it's kind of like that friend in your friend group that, you know, their kind of job is to kind of like keep everything calm and cool, and they don't like do a whole lot besides make sure nothing blows up kind of inside of your friend group. Kind of the same idea here, where the neutrons don't do a lot in an atom except for make sure all these protons that are all positively charged don't push away from each other too much and don't want to break apart. So they stabilize that nucleus, okay? Interesting thing, they have the same mass as a proton, okay? So it's not perfect, but they're almost identical in mass. So they are also 2,000 times more than that electron. So the protons and neutrons have the same mass, and electrons are very, very tiny, okay? So why do you think it was the last particle to be discovered? It's a good question, right? Well, if you look at it, we found electrons first, and they had a negative charge. We found protons second. They're kind of hidden in the nucleus. They had a positive charge, okay? Well, neutrons have no charge, okay? And in the research done in the 1930s, the way they found things is they would put electricity to it, and they would see how it responded or how it acted in electric fields or magnetic fields. Well, if you don't have a positive charge or negative charge, you don't respond to those electric fields. You kind of ignore them. So their traditional methods of finding these particles didn't work. So they had to find a different way, which involved embedding mass into wax and counting the divots in the wax and that kind of stuff, that they were able to find these actual neutrons. So no charge made them harder to find, okay? So now we know all the particles. We know that there is electrons in a cloud around the outside of the nucleus. We know there is protons inside the nucleus. We know there's neutrons inside the nucleus. We know we have the nucleus that's got a tiny little center that has a lot of mass. So we know a lot about the atom. However, the question now comes up: what about those electrons? We know they're outside of the nucleus. They're not in the nucleus. What's going on out there with them? Okay, and for years we thought that they kind of were like orbital planets going around the sun. So for years, we kind of thought they looked like this, where there was, you know, these orbits around the outside, and electrons sat on these nice, perfect little orbits inside there. But what we found out through our research, this was kind of through like the 1930s and 40s, into maybe even a little bit in the 50s, we realized that they don't really have these perfect orbits, okay? So instead, for the last 70 to 80 years, we've known that electrons are really found in what we call clouds, okay? And these clouds can also be called orbitals. That's the kind of their official chemistry name is orbitals. But we can think of them as basically being clouds. So kind of imagine poofy clouds or regions around the nucleus that you can find electrons. They have weird kind of lobing shapes to them, and they kind of have ring shapes to them. So they're not orbits, okay? So that's one thing we want to make sure is that we're not thinking that they're orbiting, okay? Now, each electron cloud does have a different amount of energy, okay? So they have different amounts of energy, and they sit at different energy levels. Now, we can see these energy levels by doing something called a bright line spectrum. We can actually see these energy levels by putting them through a prism, basically, and kind of seeing how the lights go, okay? And we can also see this through the naked eye by burning chemicals. So if we were to burn different chemicals, what we're able to see is that they actually burn different colors. So when they burn different colors, that's because the electrons are at different energy levels, okay? So yeah. Now, in class, it is going to be, we will draw the atom like this a lot, just because it's a simplified way to draw it. And instead of having to do these lobes and all these weirdness to them, we're going to draw rings to represent 1 energy level, 2 energy levels, 3 energy levels, 4 energy levels, 5 energy levels. So kind of keep in mind that we'll still use this old kind of picture. It's sometimes called the planetary model, to help us just kind of see it on the board or visualize it. But for our goal for this unit is to realize that it doesn't really look like that. It looks more like these lobing clouds that come off the atom is where they sit. So here's a quick video on how the electron clouds really look.
Thanks.
Okay, so like I said before, we are going to still draw it like this, but I thought it was worth our time to take a look at those different 3D renderings of the atoms. So you see that they are way more complex than just simple rings around a nucleus and what they are. So for our purposes, we are going to call them electron clouds, or we're going to call them orbitals, or these regions where we can possibly find the electron. Okay, now that gets us into all the basic parts of the atom and what they are. So from this video, we should know what the nucleus is, where the electron clouds are, what the electron is, what the proton is, what the neutron is, and we should know where all three of those particles exist, that the proton and the neutron are inside the nucleus, or that the electron is outside of the nucleus in the electron clouds, and we should know that the majority of the mass, or almost all the mass, is in this tiny little spot in the middle called the nucleus. Thanks, everybody.